I went back and forth on how to present this, and I think I'm going to have you guys figure it out in your groups. So everyone take a look at my first triangle here, ABC. Everyone see the congruent marks I put on there, the hash marks? Good. One side is 2. Can you guys find me the other 2 angles and the other 2 sides, please, in your group right now? Discuss how you could do that. You know the 2 sides are equal. How can you find the other 2 angle measurements and the other 2 sides? Okay, go ahead and talk it over in your group. I want you guys to think about, you guys have enough geometry knowledge to figure this out. All right.
So each
And then I can do that to say 2 BTC.
Leave any answers in simplest radical form, please. Leave any answers in simplest radical form. How do we get this?
So 4 square root 2.
Yeah.
Yeah.
Okay. No. And you got to take the square root of all, so you will c squared. It's not 16. Add 2 squared, which is 4, plus 2 squared. 4 equals c squared. And I still got to take the square root, not 8. Okay, all right, let me keep going here. We see that ABC is isosceles, don't we? And we know in an isosceles triangle, what's across of the congruent sides? Congruent angles. So if you take 180 minus 90, you have 90 left over for 2 congruent angles. So those 2 angles should have been 45 degrees. 45 degrees. AB, no big deal. It's 2 because they're congruent. I won't looking around. A lot of people, you got to do Pythagorean theorem from yesterday to find the hypotenuse. 4 plus 4 equals c squared. 8 equals c squared. C is going to be the square root of 8 because I got to take the square root on both sides. Hopefully we're comfortable in breaking that down. And that was 2 radical 2 for the hypotenuse length. 2 radical 2. Some of you guys already jumped ahead, which is fine. Go ahead and figure out number 2 now. Now you know both angles there are 45, 45. Find the missing angle and the missing 2 sides, please. In simplest radical form again, please. All right, so again, I didn't give you congruent sides, I gave you congruent angles. It's still isosceles. Missing angle, they all have to add up to 180, so that had to be in a 90-degree angle. Since I now know that those 2 have to be equal, BC is 5, and then if you did Pythagorean theorem, I'm hoping you got 5 radical 2. All right, you have just been introduced to the first special right triangle we're going to cover. What do you notice about the degree measures in both triangles? What are they? I know they're all the same, but what actually are they? 45, 45, and 90. Let me tell you, mathematicians are clever. That's what you call this triangle. So here in our conclusions, 4A, ready? That was what we call this triangle, a 45, 45, 90 triangle. It's named by its angles. First question, what do you notice about the legs in any 45, 45, 90 triangle? Look at both examples. I know it's only two examples, but it's true for everyone. In every 45, 45, 90 triangle, the legs are congruent. Legs are always equal. And now, we always did Pythag, right, to find the hypotenuse. Is there a way now I could get there a little quicker? Do you guys see any relationships between the leg and the hypotenuse in both triangles? Like if I started off this rule, hypotenuse equals, how can I find the hypotenuse without using Pythagorean theorem and just maybe using a leg? Go ahead, Luke.
Is it the same, like, that'd be the number that's the leg?
So leg, whatever the leg is,
Right.
times always the square root of 2. Always. So that's how we can find the hypotenuse on a 45, 45, 90. I can just take the leg and multiply it by radical 2. So keep these rules handy today. This is the only type of special right triangle we're going to deal with, is a 45, 45. Today, Monday's a different one. All right, so let's practice using them now. Let's practice. Numbers ready, getting called on. First, identify, do we see we have a 45, 45, 90 triangle? Done. Is the 6 a leg or a hypotenuse? A leg. So I have a leg in a 45, 45, 90. So my first question is going to be, what is BC's length then? What's the length of BC? 22? 6. And now using our rules, now you can always go back to Pythag if you forget, but using our rules a little bit quicker, what's the hypotenuse AC now using our rules? 10 or 23? 6 times the square root of 2. Perfect. No issues there? It's going to get more complicated. Don't worry. I wish it was this easy. I wish. Number 2, we see a 45, 45, 90. What's radical 5? Leg or hypotenuse? Leg. Perfect. I just want to make sure we know all the different pieces. So AB, how long's AB going to be then? 3. Radical 5. All right, here's where I need to slow down now, because I'm sure either A, you never did it last year in Algebra 1, or if you did, it was a complete show. All right, I'm sure. Okay? AC, that's the hypotenuse. Everyone agrees? What's your rule? What's the rule? Leg, which is what? Radical 5 times square root of 2. That's my rule. Leg times radical 2. Now I got to reteach, teach it for the first time. What the heck's going on here? You can't add them. We talked about that yesterday, right? The number underneath needs to be the same. So I wouldn't be able to add them, but you can multiply them. How do you multiply them? You multiply the numbers underneath. So this comes the square root of 10. All right? Square root of 10. You can multiply any radicals you want. You just can't add anything you want. And leave it like that, please. I'm not concerned about the decimal. You guys okay? This is going to be the toughest part today, is the radical stuff. Not so much knowing the rules. All right, 3. Can I get a little help? 3 radical 2. What's that? That's a leg. All right, so that's good. I was given a leg, so here we go. AB. How long is AB? 2. That's right. Every class, this drives me nuts. Different numbers. 16. For AB. 3 radical 2. All right, everyone ready? Buckle up. Hypotenuse. Just talk about the rule with me. Leg, which is what? 3 radical 2, leg times what? All right, here we go. Let's figure out how I can multiply these. Because remember, I don't want any crappy decimal answers here. No way. You can multiply the numbers out front. 3, I know nothing's there, but usually what's there if nothing's showing? A 1. So 3 times 1, 3. Radical 2 times radical 2. Radical 2 times radical 2. Radical 4, think about what you just said. Radical 4. Square root of 4. Right? 3 radical 4, that's what you guys just told me, fine, but that's 2. Right? 3 times 2. Hey, heads up! First of all, I should probably ask, did you guys even do radicals last year? Algebra 1? Nothing, maybe? All right, well, okay. And look, if you want to use this, use it. If not, fine. Anytime you multiply a radical by itself, it's the number underneath. Okay? Hey, okay, all good? Yes. Yes. So what happens with the squared and the radical? Woo, see ya, they cancel. That's where it comes from. All right, so anytime you multiply a radical by itself, it's the number underneath. So my hypotenuse here will be length of 6. So far, no problem. But so far, all I've given you is the leg first. What happens if I give you now in number 4, what am I giving you? Yeah, the hypotenuse. What if I give you the hypotenuse first? All right, no big deal. Use the rule. Use the rule. Hypotenuse equals what? Leg times. Ready? All I'm doing is using my rule. What are you going to plug in for the hypotenuse now? 8 radical 2. That's the hypotenuse. Equals. Now, can I just put L? Thanks. Times radical 2. All right, use your algebra now. How do you get rid of the radical 2? Divide both sides by radical 2, and look what happens. What happens on the left side over here? See you later, right? Radical 2's cancel, and I'm just left with 8. And that's both legs, right? Because they're all both congruent. AB and BC is 8. Write the rule, plug it in, and divide both sides by radical 2. Any concerns yet? Because we haven't even got heavy yet. Wait till this next one. Wait till this next one. All right, what's the 6? Yeah, and I know it looks familiar from the last one, but let's pretend we haven't done that a couple ago, right? What's the 6? That's the? Write your rule right now. Write your rule. Hypotenuse equals, boom, write your rule. I'm given the hypotenuse. Let's write the rule for the hypotenuse. Equals leg times radical 2. What are you plugging in for the word hypotenuse now? What's the hypotenuse? 6. Plug it in. 6 equals, and if you want to keep the word leg, if you want to change it to an X, an L, whatever floats your boat. How do I get rid of radical 2? All right, now though, unfortunately, unlike the last problem, they don't cancel out, and I can't divide those. One's underneath the radical, one's not. There's no way you're going to get a 3 out of that anywhere. So here's what I have right now. The leg equals 6 divided by radical 2. But there's a problem. And I'm sure you didn't even learn this in algebra last year. It would have been great if you did. And I'll ask somebody, anybody know what's the problem? Maybe you did. Maybe somebody did actually talk about it last year in algebra 1. Anybody know what's wrong with my answer, 6 over radical 2? I don't want the decimal answer, absolutely not. Why that answer is a problem in mathematics. If not, it's not a big deal. But no. Molly, look at that, huh? Go ahead, drop some knowledge on your classmates right now.
You can't have a radical in the denominator.
In math, not allowed to have a radical in the denominator, unfortunately. Okay? If your final answer has a radical in the denominator, that's a problem. So now, how do we fix it, right? How do we fix having a radical in the denominator? Here you go. You fix this by multiplying the top and the bottom by the radical you want to get out of there. So you multiply the top, the numerator, by radical 2. You multiply the denominator, the bottom, by radical 2. You cannot have a radical in the denominator in your final answer. Okay, here you go. I'm still going to go slow. Sorry if it's too slow. Multiply across. 6 times radical 2. What do you get? 6 radical 2 on top. Let's see if we picked anything up from today. On the bottom, radical 2 times radical 2 itself. No more radical. Magic. No more radical, huh? Right? No more radical on the bottom. But, yeah, I'm not happy with this answer either. Sure, you got the radical done. Congratulations. It's out of the denominator, but I'm still not happy with this. 6 over 2, you can still reduce. So if you can, please do so. So what's the other legs? 3 radical 2. You cannot leave a radical in the denominator. And then you multiply top and bottom to get rid of it. Thanks, Mike. You too. All good? All right, one more. And I picked a square on purpose. A square has diagonal lengths 10. Just draw in one for me. Just draw in. There's no need to draw in both. Anything you know about a square that's going to help me here? Let's start. Addie. Okay, so I got a right angle here. So it's a right triangle, yep. And Scott? Diagonals bisect those 90-degree angles. So really, what kind of triangle am I creating here? That's a 45-degree angle because that 90 is getting cut in half. And this 90 down here is getting cut in half. So everyone see a 45, 45, 90. Okay? What's the 10? Hypotenuse, right? Everyone, 10's the hypotenuse. Write the rule. Write the rule. Hypotenuse equals leg times radical 2. What do I plug in for hypotenuse? Hypotenuse, 10 equals leg times radical 2, or L. Keep doing the L there. All right, how do you get rid of the radical 2 again? Divide, yep. Can't do that, right? Everyone's good? That's a no-no. Don't try to divide. And what do I have in the denominator? A radical. Can't have a radical in the denominator. Multiply top and bottom by radical 2. Keep helping me out. What's left in numerator times numerator? What do you have on top? 10 radical 2. Denominator, 2 radical 2 times radical 2 is just 2. Clean it up a little for me, though. 5 radical 2. I wish we were done. I wish we were done. What do the directions say? Look back. Find the perimeter. Right? Find the perimeter. Well, what do you know about the sides of a square? Right? 5 radical 2, 5 radical 2, 5 radical 2, 5 radical 2. Add them all up. Or you can multiply by 4, I guess, whatever. But I'll add them all up here. 5 radical 2, 5 radical 2, 5 radical 2, 5 radical 2. Can I add those up? Am I allowed to? Yeah, because they all have 2's underneath the radical. So how do I add them? Add the numbers out in front. So how many 5's? I got 4 of them, adds up to 20. Do I add the numbers underneath the radical? No. You keep them the same, and it's just 20 radical 2. When you add the numbers out in front and keep the number underneath the same. So it looks like we have plenty of time to practice on our own here with the homework. You might want to make sure you're doing them correctly by having the answer key out. Definitely call me over. All right, if something's not matching up.